Okay. All right, here we go, guys. Here we go. Here we go. You guys ready? Focus, 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 guys. All right, from the 2003 AB exam, question number 4. I feel like this one we already did again. This was originally embedded in our notes, but it's not a big deal. We can do it again. So let's see. Let f be a function defined on the closed interval between -3 and 4 with f of 0 equals 3. So that's my initial condition. Or my, it's not necessarily initial condition, just f of 0 equals 3, right? The graph of f prime, the derivative of f, consists of one line segment and a semicircle shown to the right. Okay. So here it is. So this is f prime. Letter A. On what intervals, if any, is f increasing? Justify your answer. Guys, f is increasing whenever f prime is? Yeah, it's positive. So I'm going to write f is increasing on the interval. On what interval? -3, -2. Since f prime is positive on the interval, and I guess I'm going to be specific here, -3, to -2, but notice I'm putting a parenthesis on the -2 because right at -2 it's 0. You could have just put parentheses on the top one instead of brackets, and then you could have said f prime is positive on that interval, but I just wanted to be specific there. Anything crazy there, guys? Nothing crazy, right? Okay. Don't worry, in a little bit we'll look at the rubric. Letter B. Find the x-coordinate of each point of inflection on the graph of f on the open interval -3 to 4. So we don't have to worry about endpoints. Justify your answer. So when do you have a point of inflection? Okay, when what goes from, well, yeah, when f, right? Don't you say the word it. But I don't have the graph of f, so how do I tell from the graph of f prime? Yes. Guys, remember, if the second derivative is positive, that means f is concave up. This is f prime. So if f prime is decreasing, that means f is concave down. If f prime is increasing, that means f is concave up. Is this making sense to you or no? Okay, remember, I'll start it again from the very beginning. If f prime prime is positive, that means f is concave up. If f prime prime is negative, that means f is concave down. I don't have f prime prime, but I have f prime, and the same rules apply. So if f prime is decreasing, that means f prime prime is negative, which means f is concave down if f prime is decreasing. That makes sense? So I have 2 points of inflection at x equals 0, and where else? At x equals 2. So there it is. So I'm going to write f has points of inflection at x equals 0 and x equals 2, since f prime changes from decreasing to increasing and vice versa at those specific x values. There it is. I believe that's full credit there, guys. How do we feel? Does it make sense to you? All right, here we go. Letter C. Find an equation for the line tangent to the graph of f at the point 0,3. So I want a tangent line. What 2 things do I need for a tangent line? Point and slope. You already got your point. John, where am I going to get my slope? Guys, look, these are slopes of f. That's f prime. So what's my slope when x is 0? Yeah, positive or -2? -2. So that's probably a point right there. See, f prime of 0 is -2. Look, there it is, 0, -2. And then here's my point. So y minus 3 equals -2 parentheses x minus 0, which I guess you could leave like that, but this one's simple enough that you can just go y equals -2x plus 3. And there it is, done. Are we okay? All right. Letter D. Find f of -3 and f of 4. Show the work that leads to your answer. Okay. I think the easiest way to think of those, And let me help you out. Let me see if we can think about it real quick. Guys, relax. The easiest way to think of this as position. Think of F prime as velocity. How do you find the position? Well, find how much you moved. The area of the curved toe is my displacement. Does that make sense? Like, remember, display, okay, I'll stop. If I tell you, I'm just making this up, guys. I'm at position 2, and I tell you that my displacement is 3. Where am I going to be at my new position? I'm going to be at 5, because I was at 2 and I moved 3 to the right. Does that make sense? If I'm at position 2, and I tell you that my displacement is 4 to the left, I'm going to be at negative 2, because I moved 4 to the left from my original position. Does that make sense? So this is like, now do not write position, do not write the word position, do not write the word velocity, because it's not. It just says F prime, but it's like that. It's similar. So how do you do it? It's always going to look like this. Or at least for me, this is the easiest thing, because you don't really have to think much. It's always going to look like this, guys. F of negative 3 is equal to the initial position they gave you. F of 0 equals 3. F of 0 plus the displacement, quote unquote, integral from 0 to negative 3. That's where you got to start, of F prime. This is like, F prime is like velocity. Yeah. So, all right, let's just use proper English. And no yawning, that's a demerit. This is just telling you how much F moved. That's all it's telling you, how much F moved. Boom, boom, boom. Do you know what I mean? How many times did I move up? How many times did I move down? That's all it's telling you. And so your initial Y value plus how much you moved up or down. Cool or not cool? All right, let's find it. F of 0 is 3 plus bracket from 0 to negative 3. So I'm looking for from 0 to negative 3. I'm looking for all that. Well, this is a triangle. That's a triangle. 2 times 2 is 4 divided by 2. That's 2. So this area is 2. And then 1 times 1 is 1 divided by 2 is half. This area is half. Excuse me. We're going backwards. Child, what do you mean by going backwards? You started at 0 and ended at negative 3. So because we're going backwards, this 2 is not negative. It's positive. So 2. And this half, it's not positive. It's negative because I'm going backwards. I'm going from 0 to negative 3. Does that make sense to you guys? Okay. By the way, do you have to simplify this? No. If you're scared, you can leave it alone. But guys, we're not scared. 3 plus 2 minus a half, that's 1.5, so that's 3 halves. So I'm going to turn that 3 into 6 over 2. Right? 6 divided by 2 is 3. So I see 9 halves. There's my answer. Let me go to the other one. That's F of negative 3. I still need F of 4. F of 4 is equal to F of 0. Don't worry, we're almost done, guys. Plus integral from 0 to 4 of F prime of x dx. So 3 plus, here we go. I'm finding this right here in green. Well, you're not finding all that. You're just finding this. That's what you want. Jeff, how do I find that? Relax, find the area of the rectangle and subtract the semicircle. Do you guys see that? Rectangle. 4 times 2, 8. Don't worry, we'll take the below the x-axis into account a little bit. Minus area of that semicircle. Pi, the radius is 2. So 2 squared divided by 2. So I see 8, and then minus 2 squared is 4, divided by 2, 2. So 8 minus 2 pi. So catch up to here. Now guys, this time my integral was from 0 to 4. This is below the x-axis. So it's actually, instead of 8 minus 2 pi, the actual area of that green is 2 pi minus 8. Do you guys see that? Change the polarity. Maddie, you okay? Yeah. Are you sure? Okay. Let the record note show that her eyes are hurting. Oh, okay. All right, here we go. Bracket. And I say change the polarity, guys. 2 pi minus 8. 2 pi minus 8. So my final answer, 2 pi, and then the difference between 8 and 3 is 5, but it's the 8's larger, so negative 5. There it is. That's where I'm at 4. Cool or not cool? Which one? Let's look at the rubric. What year? 2003, question 4. So let me look at the rubric. All right, here it is. Here's a rubric. Look how they wrote it, guys. I was already warmed up from earlier, guys, so I wrote it pretty much the same as they did. Letter A, 2 points. Interval reason. The function f is increasing between -3 and -2 since f prime is greater than 0 between -3 and -2. Letter B, 2 points. X equals 0, x equals 2. F prime changes from decreasing to increasing at x equals 0 and from increasing to decreasing at x equals 2. Did we say that? We said vice versa, right? Which is the same thing. F prime changes from decreasing to increasing and vice versa. Perfect. At those specific x values. All right, we got it. Letter C, tangent line. Y equals -2x plus 3. They felt it was only worth 1 point. That's fine. No big deal. We got the point. Letter D, relax. I know it looks different than a little bit different than ours. It's the same. Look, we got 9/2, and for f of 0, or for f of for f of -3, sorry, and for f of 4 we got 2 pi minus 5. They wrote it as -5 plus 2 pi. So we got it. Cool or not cool? Okay. Let me close this one down. All right, guys, we're gonna skip this one for now, the 2009 question 6, and we're gonna go towards this one because this is the one that has FTC, which is what we covered yesterday or on Friday's the circuit. All right, don't worry, guys, we'll finish it all come Thursday. All right, here we go. Let f be the function that is continuous on the interval 0 to 4. The function f is twice differentiable except at x equals 2. But you're continuous. F itself is continuous, right? The function f and its derivatives have the properties indicated in the table above, where D and E indicates that the derivative of f do not exist at x equals 2. Okay, that's fine. Letter A, between 0 and 4, find all values of x at which f has a relative extremum. That means max or min. Determine whether f has a relative max or relative min at each of these values. Justify your answer. Okay. Find critical points where f prime is either 0 or does not exist. So I'm looking at f prime. So possible, maybe, and that's it. Those are the only 2 critical points. Okay, at x equals 1, do I have a max min or neither? Come on, guys. Yeah, neither. The derivative does not change signs. You can only have a max when the derivative goes from positive to negative, and you can only have a min when the derivative goes from negative to positive. So at x equals 1, you got neither. Look at x equals 2. I go from a positive derivative to a negative derivative. What do I have? A max. So you just say f has a relative max at x equals 2 since f prime changes from positive to negative at x equals 2. Done. Are we okay, guys? F has a relative max at x equals 2 since f prime changes from positive to negative at x equals 2. Avoid saying the word it. Do not say the word it. Maybe you can say f has a relative max at x equals 2 since the slopes of f change from positive to negative at x equals 2. You can probably say that, slopes of f. But I would not, do not say the word it. The best one to use is to use f prime. All right, letter B. On the axis provided, sketch a graph of the function that has all the characteristics. Okay, here we go, guys. First thing you do, plot the points. Plot the points. So here we go. Plot 0, -1. So go to 0, -1, plot the point. 0, -1. Let's see, what do we got? 1, 0, plot the point. 1, 0. What's the other point? 2, 2, plot the point. 1, 2, 1, 2, point. 2, 2. 3, 0. 3, 0. And do I got anything at the fourth? Nope, they don't tell me anything. Okay. Here we go. between x equals 0 and x equals 1, my derivative is positive and the second derivative is negative. So that means f is increasing concave down. So draw increasing concave down. For bonus points, look, you have a horizontal tangent at x equals 1. So increasing concave down. Horizontal tangent, boom. Increasing concave down, boom. And then from 1 to 2, so check it out, positive, positive. So that means I'm increasing concave up. Increasing concave up. Pretty steep. Boom. There it is. Increasing concave up. I have a corner at x equals 2. Perfect. So now between 2 and 3, f prime is negative. So I'm decreasing. And f prime prime is also negative. So decreasing concave down. So it's going to look like a shark fin. So there it is. Kind of looking like a shark fin there. Notice that at x equals 3, I have a negative slope of negative 3. So don't make it look like it's a vertical tangent. So it looks pretty good to me. Looks a little steep, but that's fine. We're good. And then between x equals 3 and 4, the f prime is still negative, but f prime prime is positive. So that means decreasing what concave? Concave between 3 and 4. Concave up. So decreasing, concave up. Doesn't have to be perfect. Boom. Done. We're okay, guys? Okay. So here's the big one that I wanted to talk about right here. Letter C. So go to letter C, guys. This is what we practiced with that circuit. And this is what you're going to practice today. Don't worry. The first few, you're going to fly through them. There's 2 deltas. But relax, 1 delta is due today that you're going to fly through. You're going to see it's pretty simple. And then the other delta is not due till Sunday, but I would work on it in pieces. All right, let g be the function defined by, so you have an integral. So this function is defined by this integral. Notice you have a variable on the top and a constant on the bottom, f of t dt, on the open interval 0 to 4. Between 0 and 4, find all values of x of which g has a relative extremum. That means max or min. Determine whether g has a relative max or relative min at each of these values. Justify your answer. Okay, write this down. So g of x equals the integral from 1 to x of f of t dt. The same rules still apply. I have a max when g prime changes from positive to negative, and when g prime changes from negative to positive, you have a min. So, can I take a derivative? Yes, you can. You have a variable x on the top, you have a constant on the bottom. So g prime of x is nothing more than just what? F of x. So now, and I should have written the table here, so I'm sorry, guys. So now when you look at your table, this top graph there, that f of x is g prime. See? So let's see. Don't worry, we're almost done. So g prime, which is f, is negative between 0 and 1. Then I have x equals 1 at 0. And now it looks, it's positive. So at x equals 1, g has a min. And then I go positive, and then look, again, at x equals 3, I have g prime changing signs, negative. So x equals 1 and x equals 3 are relative extrema on g. So let me write it. So I'm going to go g has, what does it have first? A max or a min? Min. So g has a min at x equals what value? 1. At x equals 1, since g prime, which equals f. So connect it, guys. Show both of them. G prime, which equals f. You can say g prime of x if you want, but my habit is just g prime equals f. G has a min at x equals 1, since g prime, which equals f, has changes from what to what? From negative to positive. G has a min at x equals 1, since g prime, which equals f, changes from negative to positive at x equals 1. I know it sounds silly to say it again. There it is. That's my first statement. Now I'm going to say the other one. G has a max at x equals, and I want to say it was 3, right? Since g prime, which equals f, changes from positive to negative at x equals 3. Say it again. There it is. G has a max at x equals 3 since G prime which equals f changes from positive to negative at x equals 3. How are we feeling right now, guys? We're almost done. We're almost done. There it is. All right, look at the next letter, letter D. For the function g, so they're still talking about g in part C, find all values of x between 0 and 4, which the graph of g has a point of inflection. Justify your answer. All right, guys, we already know this. G prime equals f. They don't tell us if g prime is increasing. Well, I guess they kind of do, but you're gonna need to do the next one. G prime prime equals f prime. So we're checking where g prime prime changes signs. Does that make sense? Whatever. I'll slow down. If g prime prime is positive, that means g is concave up. If g prime prime is negative, that means g is concave down. If I have a point of inflection, I need g prime prime to change signs. Positive to negative or negative to positive. Don't worry, we're almost done. We're almost done, Pina. We're almost done, Pina. Sorry, I don't know why I'm screaming here. All right, here we go. Here we go, guys. G has points of inflection. We haven't even looked at the table, huh? At x equals, or let's look. So this one right here, that's g prime prime. Positive, 0, positive, does not exist, negative. We're at. Oh, but Chava doesn't exist. As long as it's changing signs, that's all that matters. So there it is, and then negative, negative. So it just has one. Positive, positive, negative. Yep. So there it is. So I'm gonna write G has a point of inflection. It's not plural. So G has a point of inflection at x equals what value did we say? 2. Since G prime prime, which equals f prime, changes. Do you want to say changes signs or changes positive to negative? It doesn't matter which one. Changes signs. Okay, changes signs. Since G prime prime, which equals f prime, changes signs at x equals 2. You could have said changes from. What did it change from? You could have said changes from positive to negative. That's fine. You would have gone full credit. And there it is. Let's see the rubric. What year was this? 2005? All right, here it is. Look at that, guys. F has a relative maximum at x equals 2 because f prime changes from positive to negative at x equals 2. We got it. Letter B, our graph looks like that graph. It's going to look like that graph. We got them all, 2 points. So far we got 4. Letter C, G prime equals F equals 0 at 1 and 3. By the way, look, and I think this is very generous. Sometimes they do that. I think they do this almost all the time. I want you guys to notice this right here. Look, they will give you a point, guys. They will give you a point if you just state, look at this 1 point right here. If you just state G prime equals F, you get a point. Why do you get a point? Because that is fundamental theorem of calculus. The derivative of the integral is whatever you have in the inside. So guess what, Kanduru? They'll give you a point for saying that. I am shocked. Let it be known that Miss Kanduru is shocked. Happy birthday, Miss Kanduru. I'll stop. All right, there it is. So we got a point. Yeah, look, we got everything. Look, G prime changes from negative to positive x equals 1. So G has a relative minimum at x equals 1. G prime changes from positive to negative at x equals 3. So G has a relative maximum at x equals 3. We got them. Letter D. The graph of G has a point of inflection at x equals 2 because G prime prime equals f prime changes sign at x equals 2. Ours is verbatim to theirs. If you don't want to, I mean, you could have said changes from positive to negative or whatever one it was. I can't remember. What do you guys feel? Do you guys feel like this is coming all together? Like we're getting stronger? All right, guys. I'm going to try my hardest to give you a schedule of the remaining, the Saturdays. I'm going to try my hardest to hook you guys up. If you can't make it to the mock exam on a Saturday, see if you can take it in pieces throughout that week because I want to make sure to give you feedback on what you're good and what you're not good. All right, guys. Log into Delta. Take care of that one today. You'll probably fly through the first one. You do got 2 of them, but the second one's not due till Sunday, and that's it. We're good.